Hello and welcome everyone to this live webinar on the future of food packaging and how we navigate the new demands in food packaging when we move towards more sustainable and recycled materials. My name is Penny Bergman and I'm a business development director in sustainable materials and packaging at RISE, and I will be the moderator for today's webinar and will guide us through the coming hour together with 5 experts joining me today. And I'm very happy that we have about 170 people listening in from different parts of the world. This is an important topic. The future is circular, but as producer, we need to address multiple challenges to balance food safety, sustainability, and market demands. If you're not familiar with RISE, it stands for Research Institutes of Sweden and comprise of over 3,000 researchers and experts in different fields. And we work to increase innovation in the bridge between universities research and development at companies. And our aim is to help you on your journey for a more sustainable future. If you're interested in more information about RISE and what we can offer, don't hesitate to contact me directly or visit our website, www.ri.se. Some general information before we start. The webinar is recorded and we will make it available on our website afterwards. If you have questions, please add them to the Q&A and you will find it somewhere here with a question mark. And we will have some time in the end to ask questions. And this question section will not be recorded. And of course, if you have additional questions or think of questions afterwards, you're always welcome to contact us at RISE. For the program today, we will hear 5 presentations on different aspects of food packaging materials. We will begin with looking into the possibilities, but also the challenges we face in bio-based and recycled alternatives to plastics in packaging, followed by legislation aspects and microbiological as well as odor aspects in food packaging. And then we end with a crash course on eye tracking and consumers' interaction with products with an example of seafood choices. First, I welcome online. We have Oskar Westin, business developer at RISE, with a special focus on bio-based materials. And you will talk about the alternatives to plastics in packaging. Welcome, Oskar.
Yes, thank you. This was the title of my talk, bio-based recycled alternatives to plastics in packaging. Of course, given the amount of time we have each in this presentation, it's hard to cover everything. So it will be a sort of a slice of things that are happening and that you can do. And I want to start this with looking at or introducing the concept of the value hill to those who are not familiar. It's a way to consider that when we produce a product or a material, with each step in that chain, we are adding value to it. And ideally, what we want to do is we want to keep the material or the product with as high value as possible for as long as possible. So you want to keep it in use. You want to maybe reuse it, maintain it, repair it as much as possible in general. But of course, for packaging, this is not the case. I mean, you don't tend to repair your packaging very much. You use it once, and oftentimes it's a quite short life cycle. And in the best case scenario, you have this kind of interaction that you produce your packaging, it is used by a consumer at some point, and then they leave it with the recycling. And that's all good and fine if you have this loop and you can close it, then you have a circular material, and that's great. But of course, what is happening a lot is that it doesn't reach the recycling, and we lose it, and in that case, the best scenario might be incineration, and the worst scenario is that you end up in the nature. And if it's a plastic packaging, it starts to decompose into microplastics and contaminate seawater or other parts of the environment. And that's what we want to avoid. And that's really the impetus behind replacing plastic material. I want to show you this slide just for 1 second to give you an idea that in RISE we work, all over this value chain of packaging. If you want to get into it more, you can watch the recording and go back, or you can just get in touch with me. Because what I want to do is get into some basics. And since the topic here is alternatives to plastics, we need to start by looking at what are plastics offering. And the benefits of plastics is it has transparency, which is quite important, particularly for food packaging, where you want to be able to assess the state and the quality of the product. It provides barrier properties, so it keeps contaminants from reaching the product. And it also encapsulates aromas and things like that in the product. It's stretchable, so in some cases that's quite important in order to conform to various types of content, various types of product. It's shapeable. Now, actually, I should have brought out a laser pointer so you can join me. So it's shapeable, which means that you can produce packages that are adapted to the content. And those are very, very good benefits of using plastics, of course. But you can turn it around and you can look at cellulose fiber, which is the sort of main alternative that we're looking at, and say that these are all challenges for cellulose fibers. Typically, cellulose products, paper, is not transparent. It's not really a good barrier because it is made up of fibers, and the fiber structure, fiber network, that generally speaking is quite porous and tends to be a poor barrier. And it also has quite poor stretch. The cellulose itself is a stiff material, and in a bonded network, it's quite hard to conform it. It will break rather than stretch. And generally, it's also not shapeable. I mean, you get it, and it's for that same reason. You don't have the stretch, so you can't really reshape it into interesting forms. And typically, you have it in 2D flat shapes. And then, of course, there are many nifty ways of using origami and things like that to create shapes from the flat material, but it's still a challenge. And then I will add also water, since the cellulose itself is it interacts quite heavily with water, and once it's in contact with water, it will start to disintegrate the bonds between the cellulose fibers. So these are all big challenges, particularly if you want to go into food packaging. And I want to look at some things that you can do to counter this. Now, if we start with the water thing, fighting water. So what you can do is in wood fiber, you have several components. One of them is cellulose, one of them is lignin. Now, lignin is a naturally occurring thermoplastic. So if you subject it to heat and pressure, it will reconform. And so if you compress a lignin-rich paper, then you can actually increase the strength in water. So what you see in this graph is the resistance to tension when the material is wet. So what we see here is that if you pass around 150 degrees, you go above that, you start to reconfigure the lignin, reconform it, and it bonds the fiber structure together, and you get a material that's actually can withstand being wet and does not break once it's wet. And this is done without any chemical additives. I would say that some of the things that I present here, of course, we can already do them by adding, for example, plastics or polymers in some way that are maybe not biodegradable. So what we are looking for is, of course, things that are environmentally friendly. So this is another, so when we do this hot pressing, we also actually improve the barrier property. So what you see in this graph is what's called a contact angle measurements. You don't need to really understand the details of it, but what it shows is the interaction of water with the material, with the surface of the material. And so between this untreated material and the green line, what we see is, okay, there is an improvement of the interaction between water, and we get a better water barrier just by hot pressing it, but it's not really very good. It still interacts, it still gets wet. So we get inspiration from nature, and we look at birch bark, and we use a compound called betulin in that material, and we can coat the paper with that, and what we have is a natural barrier to water, and as you can see here in this purple and blue lines, that works really well actually, and maintain the droplets will not sort of be absorbed in the paper, they will remain on the surface. And I can feel my time is running away, but I want to say also shaping up. So the shapeability and stretch is also things that can be addressed with wet forming. I think most of you who have been to or purchased food at some point in the last couple of years will have had this kind of paper trays that you can take and that are recyclable in the paper recycling chain. And that is done, of course, by reconfiguring the paper making process into where you're able to make 3D shapes. And this can be done using water as in the paper process, but also as using air as a medium. And we call that dry forming. And there are several examples of that. And we can also buy some nifty mechanical and other tricks. We can make paper more stretchable and address that thing as well. Now I think I'm actually running out of time here, so I will skip really quickly over this one, but mention that using other techniques, we can make sort of a lightweight replacement for EPS plastics, for example. And end on this note that we can sort of reach all of these different properties, but in the end, I think what needs to be considered is what do we really need and what is just nice to have. So we can get transparent materials, but it might be expensive and it might be difficult to get all these properties at once. But what fiber is offering is recyclability and biodegradability, which is really important, particularly if you're not able to reach a high level of recycling, then the biodegradability becomes really important. So if you want to get into it more with me, feel free to get in touch. And with that, thanks for my time.
Thank you, Oskar. Very interesting. And I think the needs and niceties is really something that we need to look into. As I said in the beginning, we will wait with the questions until the end of the webinar. So please add them to any questions that you might have, add them to the Q&A. And we will go through it afterwards. And instead, we will focus on Hans Steyer, our expert in food contact materials regulation. Welcome, Hans. And you will address the legislation of for food contact materials.
Thank you.
Yeah. Thank you.
So, okay, I have a presentation as well. And I will talk about the evolving legislation on food packaging. And for this, I will use the acronym FCM, Food Contact Materials. And for clarification, the meaning of this will also cover the final products to be used in contact with food as I use it today. As a base of the presentation, it might be worth to see where we are today without going into details. All food contact materials are covered by two legislations. The EU Framework Regulation sets requirements on the materials. The processing and handling of them then are covered by the Regulation on Good Manufacturing Practice, GMP. The framework is an umbrella for all types of FCM, and the core requirement is that FCM shall not transfer its constituents to the food during its use in quantities that could endanger human health. It is also stated that FCM by principle shall be inert and not change the properties of the food, nor deteriorate the odor and taste of the food. Oh, sorry. The intention of the framework was that there should be specific regulations for each of the materials under it. But this has only happened as intended for plastics and a few more. Instead, there are still national regulations or recommendations that are used when assessing other materials, for example, paper and board for the EU market. And one trend now is also to remove substances from the lists of evaluated substances based on updated toxicological evaluations. And there is also an ongoing discussion on how to reform the system and make it work better. The coming update for plastic FCM will focus on the purity of the actual materials and will more clearly define how also NIAS should be handled. NIAS meaning non-intentionally added substances. And even if the final material has to be assessed, it is thought that much of the information should come from earlier stages in the value chain. The composition shall be known to the manufacturer of the substance, and the migration screening now put down 2 limits. NIAS shall not migrate over 0.05 milligram per kilogram food if identified and not genotoxic. Or if it's not possible to identify, or if genotoxicity cannot be ruled out, the limit is 0.00015 milligram per kilogram. I also would like to point out the coming packaging and packaging waste regulation. The scope of this is more than just food packaging, but it's important to understand to be able to comply with also for FCMs. As a start, there is a requirement to reduce the amount of packaging waste generated in the EU. There will be more strict rules on weight and volume, need to only use a minimum of packaging material to fulfill the function. It will also be requirements to make all packaging on the EU market recyclable by 2030. The use of reusable packaging and use of recycled content will be promoted and to some extent required. And all of these requirements will be adopted and the same in all EU without national interpretations. At least that is the aim of a EU regulation. That was the first introduction to the current situation, and now to one of the trends we see, namely ban of substances that has been used until now. My first example will be the substance bisphenol A. This weak acid can be used in various applications, but perhaps most common in lacquered FCMs. The specific migration limit for bisphenol A has gone from 0.6 milligram per kilogram food to 0.05 milligram per kilogram in 2018, and now updated legislation soon to be in force will in principle ban all intentional use. So the risk assessments done previously have been replaced with a more strict one, and the use is no longer possible given the new tolerable daily intake. The other example is that a broad group of substances will be banned, namely PFAS. The acronym stands for per- and polyfluoroalkyl substances. They are all man-made synthetic substances, and the variety over 10,000 possible substances. The definition is that if at least one fluorinated methyl or methylene group is present, it's a PFAS. The ban will be given in the coming PPWR, pointing at food packaging specifically. But having said that, we also see potential conflicts coming up in the near future. The FCM legislation is dealing with food safety and cannot be compromised with. Rather, risks need to be assessed and managed, also based on updated scientific findings. At the same time, we need to address overconsumption of limited and fossil-based resources, calling for more circular use of packaging materials. Also, if the packaging do not fulfill its purpose by protecting the food as good as before, it will probably result in increased food waste. And again, what we see a lot of a problem might be, what about chemical contamination in recycled materials? Other speakers will address other parts of this, but in my field we work with how to handle the chemical contamination in recycled materials. To wrap things up, I also would like to give you a brief look on what we might see a couple of years ahead. Today's framework legislation never really took off as expected, so there is a need to take a new approach. The ideas from legislators point out that material will be grouped broader. For example, will plastics, adhesives, printing inks and other synthetic materials be one group? Metals, ceramics and glass will be grouped as inorganic materials, and the third group might be more bio-based materials, including paper and board. Also, the system with positive list has proved to be slow and resource demanding. Instead, there is an idea of a more tiered approach with banned substances in negative lists, keeping the positive lists where they do their job, but also open for more possibility to use more benign substances on their own responsibility based on guidance documents. And with that, I hand over to the next speaker.
Thank you, Hans. Look forward to hear more about how we can use recycled materials in the future. Then we take a step over to the world of microbiology and microbiological considerations to take into account. And I welcome Birgitta Bergström online, our expert in microbiology. Welcome.
Thank you. So the microbiological considerations for food packaging. So I am focusing on this food contact material that Hans was talking about. So you can take the next picture. I will focus on why there are sometimes microorganisms and toxins in these food contact materials. And then I will go into if that is a hazard and could we expect an increased problem when more and more new material are recycled or reused. And finally, I will talk a little bit about how we can assess and prevent microbiological hazards in food contact material. So, this is some pictures from the real world. When we collect and store the material, there can be a lot of microbiological issues, especially if we have a lot of nutrition left in the packages. And if the temperatures are high, we can have heavy growth. And some of these pictures are from a project where we assessed work environment risks from air contaminated with microorganisms. And we followed and assessed the microbiological risks all the way from the deposit machine that we can see in the middle here to the waste facility center. And this could be a really hard work environment risk with this contaminated air. And here we can see if we have a high contamination level into the paper mill, we can have a lot of problem in the paper mill because we have the paper process offers perfect growth possibilities with high temperatures for about 30 to 50 degrees and sometimes long holding times. And of course, we have this heat inactivation, and if we have a lot of microorganisms, we have to have a more effective heat process in the paper mill. The results is though that there will be microorganisms in the you can take one step back, please. In this final product, you will have spores and you might have toxins, and you have to assess if that is a risk or not. And the final product, of course, don't have to be sterile or so, but it has to be fit for its purpose, and you have to match it with the type of product and the sensitivity of the product that you're going to put into this material. So, is it a problem then if you have microorganisms in these food contact materials? So far, we have not found any published cases where there are pathogens that have migrated from these food contact materials to food and caused illness. But there are cases with spoilage microorganisms causing food alterations and sensory problems with food contact materials. And holes and discoloration is also a very known problem from microorganisms in packaging material. And there is also a lack of scientific and technical information regarding microbiological quality of food contact material. Microbiological requirements are mostly also missing in the regulations regarding number and types of microorganisms and toxins that are allowed in the material. So microbiological risks with using more recycled and reused material for food contact material should not be disregarded, but you have to assess and prevent it. And how can you do this then? You can work with different quality management systems that you have to implement. And Hans talked about this good manufacturing practice that states that there must be a quality system for all stages of the production, processing, and distribution of materials and productions intended to come in contact with food. And to add up with this, you can also work with HACCP, that is regulation in the food system, hazard analysis and critical control points, that is a preventive approach to food safety that identifies, evaluates, and controls hazard throughout the production process. So I want to sum up with the recycled packaging material and reusable packages can absolutely introduce microbiological hazards. And these are some examples of how RISE can assist you. We can perform these microbiological risk assessments all along the process chain to identify the hazards coming in with the recycled material, set the critical control points and measures. For example, in the paper mill, we can follow the material in what it brings with it as microbiological hazards and set these time temperatures, for example, measures to inactivate the microorganism to have a safe product in the end. We can also work with the evaluation of transfer of microorganisms from food contact materials to food. We can test and recommend how to clean food contact material if going to reuse it. And we can analyze microorganisms and toxins in or on the food contact material, quantification and identify the number and sort of microorganisms and toxins, if there are some in the material. And we can also, I was thinking of these biodegradable materials, we can also test and verify that they work in the way that you expect them to do in contact with the food, of course. And inside the package and packaging food, we can also not work with microorganisms in the food packages. So thanks for listening. And if you have microbiological questions, please don't hesitate to contact us with them.
Thank you, Birgitta. For non-microbiologists, it always sounds a bit more, it sounds a bit scary with the microbiology, but it seems like you have, or it's good that you can always contact you for these questions. And I will transfer to maybe less dangerous, but still very important topic of for our perception of the food packaging material, and that is the odors and aromas and how we can detect these in different ways. And I welcome Diana Osienka, a researcher in aroma chemistry. Welcome.
Yeah, so today I will be talking about the detection of off odors and aroma compounds in food packaging. And as my previous colleagues already addressed, reuse and recycling of packaging material is an important measure to reduce the high amounts of packaging waste, to reduce the environmental impact that is caused due to this. However, there are several requirements that a food packaging material needs to fulfill. So, on the one hand, it's important that the packaging material protects the packaged food from light, air, or moisture, so that no oxidation processes are happening, which, for example, could also lead to rancid off odors. But on the other hand, it's also important that the packaging material itself does not transfer any odors to the packaged food. So, in general, the packaging material should preserve the food quality and the sensory characteristics, such as taste and aroma. However, reused and recycled materials hold the risk of such odor transfer, which then might lead or affect the consumer acceptance and then lead to consumer complaints and maybe the consumer's decision not to buy this product again. So, to give an example, a research study that was conducted at Rice investigated the off odor of reusable PET bottles, which was caused due to consumer misuse. And here, researchers found out, due to the chemicals that were detected, consumers probably filled in fuel or laundry detergent into these PET bottles, which later caused the off odor. But it's not only about the consumer misuse. In general, post-consumer recycling material is affected by such an odor transfer. And this is the reason why it's important to analyze volatile and aroma active compounds in packaged food, but also the packaging material. And in the next slide, I would like to present the method that we use for aroma analysis. So it's the gas chromatography, mass spectrometry, and olfactometry that we use, or short GCO and GCMS. Of course, first in the beginning, we need to extract the volatile compounds from the sample. Here I displayed a bottle, as I previously referred to one of our studies, but it can be any sample. So we can analyze solid or liquid samples, but also air samples, for example. So after the volatiles were extracted, the extract is injected into the GC system, and here a carrier gas transports the volatile compounds through the column, where the compounds are separated according to their chemical and physical properties. And then after separation, the gas effluent is split, and one part goes to a conventional instrumental detector, for example a mass spectrometer, and then we get such a chromatogram, as you can see. And here every signal, so every peak, corresponds to a volatile compound. But at this point, we don't know anything about the odor of the volatile compounds or the odor intensity. And this is the reason why we used an additional detector, the so-called sniff port. And this is actually our human nose. The other part of the gas effluent goes to the sniffing port, where a person is sitting and actively sniffing during this GC run. And every time the person perceives a smell, the odor quality, but also the odor intensity is noted. So afterwards we can combine the olfactory data with the instrumental data, so we have a complementary odor profile. And what's really interesting, or also the main advantage of GC olfactometry, is that the selectivity but also the sensitivity of our nose is so different compared to an instrumental detector. So this is also why it's usually the case, or often the case, that the most abundant peaks in such a chromatogram do not correspond to the most intense odors that we humans perceive. And sometimes our nose is even so sensitive that we can detect trace aroma compounds where we can barely see a detector signal. Yeah, so we here at RISE have the expertise to conduct such chemical analytical analysis, or short GCMS and GCO, to identify but also to quantify the aroma active compounds. And further, I would like to add that we also have experts here working with a trained panel to conduct sensory evaluation, which then directly reflects the consumer perception. So to answer questions like, what's the overall global odor that people actually smell? Or which are the most pronounced odor qualities that are perceived? Because in GCO, the aroma compounds are separated and then individually evaluated and identified. But then, while the sensory evaluation then with a panel takes also the mixture effects of all these different aroma compounds into account. So this is the reason why the combination of both approaches can be very beneficial. And now, to conclude, it's important to analyze volatile and aroma-active compounds in packaged food, but also the packaging material itself to ensure the food quality and to identify possible off-odors. And if we identified the compounds that potentially cause these off-odors, it's then possible to trace back the origin and also possible formation pathways. And then it's possible to specifically address this problem and take measures and optimize the process to reduce off-odors and to ensure the sensorial quality of packaged food. So I have a question now for you. Have you ever received consumer complaints regarding off-odors? Or are you maybe currently working on new innovative packaging solutions and would like to find out more about the aroma profile, or how does it interact with food or any other consumer good material? Then please feel free to contact me and we can further discuss and collaborate. Thank you.
Thank you, Diana. It's always so fascinating, this combination of use between using people and their fantastic capacity together with machineries that have can measure it on the tiniest aroma and
I agree.
volatile component.
Thank you.
Thank you very much. For our final presentation, we will dive into consumer perception and eye tracking. And it will be with a case presentation on seafood products. For this, I welcome Elena Costa, PhD candidate on barriers for seafood consumption. Welcome.
Thank you, Penny. All right. So today I'll be speaking about eye tracking as a tool to measure consumers' interaction with products. But first of all, for those of you that are unfamiliar with eye tracking, we need to say that eye tracking is a technology that measures eye movements in order to investigate visual attention and behavior. And this technology consists of near-infrared light and a series of cameras that allow you to detect exactly where a person is looking. And this allows you to understand cognitive processes. Because what we look at is closely related to what we think about, and therefore what we do as a consequence. And there are two main types of eye tracking. Screen-based eye tracking, for when we are interested in stimuli that is presented in a monitor screen, or wearable eye tracking, when we're interested in stimuli that is presented in the real world. And for this, we use the eye tracking glasses that you can see here on the right, on this picture. Now, eye tracking is a non-intrusive tool to capture natural behavior when we're interested in a specific task. But it is not meant to be used in isolation, but rather as a combination between this method and other research methods. For example, it could be surveys, or it could also be interviews. But why eye tracking? Well, as humans, we are heavily reliant on our visual system. And vision is our primary sense to perceive the world around us and to really take important decisions. However, our visual system has important limitations. So we might perceive the world around us with high resolution, but in fact, this is not really the case. So not everything around us in our visual field, in what's in front of us, is perceived in high resolution. In fact, we only have high resolution in a very, very small area, which we call the fovea. And this area is approximately 1 to 2 degrees of our visual field. And just to imagine how small this is, you can think of it as the size of your thumbnail at an arm's length distance. So this small area takes in very detailed information, and as we move away from the fovea into the parafovea and peripheral visions, we have information as well, but it's much, much more blurry. And you can see the example here below. So in order to see objects sharply, we need to constantly be moving our eyes from one area of attention to another. So we need to direct our fovea to one location to another, and we do that through saccadic movements, which are extremely fast jumps. And when our eye is extremely still in an area, or relatively still in an area, we call this a fixation. So why is this important when it comes to packaging design? Well, understanding that our visual field, our visual system has limitations is fundamental when it comes to packaging design. Because when it comes to the retail environment, there is a lot of visual competitive space. It's a retail environment that has a lot of stimuli and is competing constantly for the attention. And time is often quite limited when it comes to consumers' decisions, and decisions are taken in a really fast, in just a few seconds. So when it comes to packaging design, it is key to ensure that products are seen, considered, and purchased. And we can think of a few examples where it comes to eye tracking. So for example, when you have a new packaging design, does it improve product findability? Is the new packaging design more visible against the competition? Are the most relevant claims for consumers effectively communicated through the packaging? And how do consumers interact with a new packaging design? These are some of the questions that we can address with eye tracking. So just to illustrate the type of outputs that we can obtain with eye tracking, I would like to show you just a few slides from a project we did recently where we explored seafood choices at the point of purchase. Now, this study was published in the British Food Journal, so you can always go there in case you want to read about it in more detail. And in this study, we actually had this main goal of understanding the factors that shaped seafood choices among current consumers here in Sweden. We also wanted to understand the perceived importance of seafood sustainability, as well as consumers' recall of labels. And as I mentioned before, it is fundamental to combine eye tracking with other research methods as well. So in this case, we utilized wearable eye tracking with semi-structured interviews, qualitative interviews, on 39 consumers. So we recruited consumers before they entered the store, consumers that were interested in actually buying seafood products that day, and we recorded their entire journey from the entrance in the store until the end of their journey, including when they were purchasing products in the seafood category. And at the end of their journey, we interviewed them through a retrospective think aloud method, which means that we replayed the video where we recorded the moment in which they were purchasing the seafood products. And here we can see an example of a respondent that is purchasing from the fresh counter. And here you can see that the red dot illustrates the fixations, so those moments when the eyes are relatively still in one position. And in this moment, we're processing information. But you can also see the jumps from one point to another through these lines, and these are the saccadic movements. So here you can see that the respondent interacts with the staff member at the fresh counter in order to take a decision between two different types of products, the salmon on the right and the salmon on the left. And this participant interacts with the staff in order to conclude on this decision and also perceives this material that is displayed on the counter. So this brochure that you can see has been also read, and this consumer indeed takes the brochure home as well. Right. So this is, of course, one respondent. But when we aggregate the results across different respondents, we can, of course, obtain visualizations and metrics in order to conclude from the results. So in this case, we saw that most of the attention was driven towards the product imagery, the price, and the name. Whereas, on the other hand, we see that sustainability information and labels were perceived in a less level. So you can see that there is less attention on these areas. And here we looked at this through time spent on these different areas, but also through heat maps here. We can, of course, obtain a lot more metrics other than total fixation duration. There's a lot more metrics that you can obtain. But in this case, we looked at this one, and you can see that when you see the sustainability labels and sustainability information is actually not as visible as compared to imagery and price and name. So what we could see is that even though consumers had high awareness about the sustainability information and labels, this did not always translate into action at the point of purchase. And therefore, sustainability information faces a strong competition at the point of purchase and should be communicated more effectively in order to make action on consumers. So some key take-home messages from eye tracking is first that it is a useful tool to investigate consumers' visual attention and behavior. But it is not meant to be used in isolation. It is best to combine it with other methods, such as surveys and interviews, in order to fully understand the consumer's experience with products. And eye tracking allows you to see from consumers' point of view, to evaluate and compare different packaging designs. Now, this allows you to understand whether your designs in the packaging are being perceived as you intend them to be perceived, and if they are leading to the desired action that you expect. And this is fundamental because the time available with consumers, especially in the retail environment, is extremely limited, and evaluating and optimizing packaging design is fundamental. Thank you very much for your attention, and I'll be here for questions later.
Thank you, Elena. And it's really fascinating with this, how little or how important it is with the communication, and what do we see when we address sustainability and sustainable materials.
Absolutely.
Thank you very much. We have now come to the end of the presentations, and we will soon turn off the recording and look into the questions in the Q&A. I know that some of the questions have already been answered, but we will have a look into it. I would like to take the opportunity to first thank all of our experts for your insights in the different areas, and of course everyone that has listened to this webinar. I hope you have enjoyed it as much as I did. My takeaway messages from the seminars have been this: how we can use the inspiration from nature and use what is now considered waste, and how we can work with both forming and stretchability to kind of approach the plastic similarity from bio-based materials. But also on the new legislation, and how it feels very comforting to know that recycled materials will be both promoted and in part required, and a much needed step to take us forward in this. As long as that we can actually assess and prevent microbiological hazards and what the risk is, and the importance of a stepwise procedure or informed procedure, and all the challenges of migration and contamination that can cause off odors, and finally the most intense crash course in eye tracking, but also how good a measure it can be to understand what consumers perceive and what we can do to simplify it for consumers forward. For me, I think this, even not sure of all, everything is in place, of course, with using recycled materials. There is a path forward, and that feels good. So thank you, everyone. And I would like everyone to join me for the questions. and we will stop the recording. And before we begin, I would say begin with the questions. If you have questions that you want to ask later or just to any one of us, please let us know and feel free to contact us at RISE.